All right, guys, STAT 1800. Going to be probably a pretty lengthy video, so that's the beauty of having lectures recorded is if you want to watch half of it now and half of it later, you can. Okay, a couple of things. One thing that you should go ahead and do is on Blackboard there is a folder called Handouts, and there's two handouts that I'm going to cover in this video, and one of those is titled Final Handout CIs, and the other is called Sample Size Calculation. So these two handouts again are on Blackboard. I would, if you want to play along, go ahead and and download these. If not, kick off your shoes and prop up your feet and let me teach you something. All right, gang. The purpose of this video is going to be kind of twofold. First of all, I want to review all three types of confidence intervals that we've studied so far. Those three types are confidence interval for mu, where sigma is known. This is called a Z interval. The other type is a confidence interval for mu, where it's unknown. Sigma is not known. This is called a T interval. And a confidence interval for P, which is a percentage, and this is referred to as a one prop Z interval. The second thing I want to do is I want to teach you some new stuff. And the new thing that I'm going to teach you is how to calculate a required sample size to achieve a desired margin of error. So, a lot of times people will conduct studies and they'll usually due to sample size, they'll find out that their margin of error is too high. Maybe it's 5, 6, 7, kind of the industry standard in these confidence intervals is to have a margin of error at 3% or lower. So let's say someone goes out and conducts a study and they calculate a confidence interval and their margin of error is maybe 6 or 7%. So it would be needed to know the procedure by which you could calculate the desired sample size, calculate the sample size to create a desired new margin of error. All right, easy for you to say, right? So guys, I've got, right now, I have the handout. I'm pretty sure this is the one that says Final Handout for confidence intervals. So I'll tell you what, I can probably come down a little bit and make that just a little bit larger. So the first question here says the National Center of Education Statistics would like to estimate the length of time required for students to complete their bachelor's degree. Collect a random sample of 20 students who have a mean, I assume, length of time to create their graduation, their bachelor's degree, of 4.8 years. Population standard deviation is known to be 22. So guys, what I take from this is I know my sample size is 20. I know that my sample mean is 4.8 years. And my population standard deviation is 2.2. So what's the value for mu? Well, we don't know. The mean mu in this situation is the length of time required for all students to complete their degree. This X bar, 4.8, is just for the 20. All right. So the first question says construct a confidence interval. Well, gang, I'll tell you what I'm going to do. I'm going to go to StatCrunch to do this. So I'm going to go to Stat. I'm going to go to ZStat. I'm going to go to one sample. Guys, if you don't have StatCrunch up, just pause me. Get StatCrunch up and hit play. I'll be here. All right, so sample mean is 4.8. The standard deviation is, what, 2.2? And the sample size is 20. And guys, we want a 95% confidence interval. So the left limit is 3.84. And the right limit is 5.76. I'm writing this down so it'll be there when I get back over here. All right, calculate the margin of error. Well, guys, the margin of error is going to be 5.76 minus 3.84 divided by 2. Let me grab my calculator. And I get 0.96, so plus or minus 0.96 would be the margin of error. Now, new stuff. That should have been just review, but this is new stuff. What sample will reduce the margin of error in half? So if I take the 0.96 and reduce it by half, this tells me that I need my new margin of error to be 0.48. Well, guys, we know that the margin of error is found by taking the z critical sigma over the square root of n. So I just need to plug and chug the information I have in this formula. So I want my margin of error to be 0.48. I know the z critical for a 95% confidence interval is 1.96. And guys, don't put the plus or minus in there, because technically you got a plus or minus here and you got a plus or minus there. That just confuses the algebra, because the plus and minus would cancel out anyway. So just leave it out of the calculations. Guys, sigma is 2.2. And over the square root of n. So ultimately we need to find for n, which will create this. All right, so what I'm going to do is I'm going to divide both sides by 1.96. And I get this. Next thing I'm going to do is I'm going to use a trick. And there's a trick that says when we have a proportion, we have a ratio, we have a fraction equal a fraction, that the values on the diagonals, I can just switch those and not lose the equality. Now let me show you what I mean by that. Does everyone agree that 1/2 is the same thing as 5/10? Well, you should. This property says I can switch that 10 and 1 or the 2 and 5 as long as it's on the diagonal. I can put the 10 up here, put the 1 down here, leave everything else as the same, and I don't violate the equality. Same thing here. If I have a 1 over 5, it's the same thing as 2 over 10. So I'm going to do that over here. I'm going to switch the 0.48 in the square root of n. to get this. And then I'm going to multiply both sides by 1.96. So those cancel. So ultimately, guys, what I now have, on the left-hand side, I have the square root of n. And on the right-hand side, I have 2.2 times 1.96 divided by 0.48. Next thing I need to do is I need to square both sides. So ultimately this comes down to n equals what? 2.2 times 1.96 over 0.48 quantity squared. Now let's put that in our calculator. Quantity squared. So I get 80.70. Well, I can't have 0.70 of a person. So guys, anytime you're rounding, solving for a sample size, you throw traditional rounding rules out. So in other words, if this is 5 or bigger, we round 81. If it's 4 or smaller, you keep it at 80. You throw that out the window. If it's anything bigger than 80, 80.00001, you round up to 81. You always round up when solving for a sample size. So guys, our sample size here would be 81. Now, you may have been screaming at the screen saying, Darber, why are you doing all this? I mean, why are you not just solving things little by little? Why does everything have to be in this form? Well, guys, what I want to do is I want to create a general formula. When you have a z interval, how can you calculate easily the sample size to get a particular margin of error? So guys, let's think about this. This answer essentially has 3 parts. What role did the 2.2 play in this problem? That was our sigma. What role did the 1.96, awful sloppy there, but we know it's 1.96, what did it play? That was the z star. What role did the 0.48 play? That was the margin of error. The reason I kept it in this form is I wanted to create a formula for you guys, so when you run into a problem like this again, you can just go directly to the formula. You don't have to do all the algebra. Put the population standard deviation value right there, put the z critical right there, put your margin of error there, divide it out, multiply it out, square it, round up. Guys, you get the sample size that you need to create the proposed margin of error. All right, number 2, in a recent sample of n equal 1,020 job applicants, 58 failed their initial drug screening test. Well, that's kind of sad. In fact, I would say in some areas it would even be higher than that. But anyway, we wish to use this information to estimate the percentage of all job applicants who fail their initial drug screening test. So guys, I know that p hat is x over n, and x in this case is the count out of the whole who has what I'm measuring, and the n is 1,020. The value for p or pi is unknown. So what I want to do is I want to create the confidence interval. And again, I'm going to go to StatCrunch and do that. So we'll go to Stat, go to Proportion Statistics, one sample with summary. So the number of successes, I don't know if failing a drug test, being a job applicant who fails a drug test is a success, but in the language that we use in statistics, that's what it would be called. So 1020, we want a 95% confidence interval, so compute. So guys, the left bound would be 4.3% or 0.043. And the right bound would be 7.1% or 0.071 if the answer needs to be as a proportion. So I've written that down. So if the answer needs to be in a percentage form, here's what we got. If it needs to be in a proportion form, same thing. Nevertheless, the margin of error is going to be the big number minus the small number divided by 2. So 7.1 minus 4.3 divided by 2. So we get a margin of error of 4% is what I get. All right. Now, what sample size will reduce the margin of error to plus or minus 1%? So the first thing you got to remember is 1% is the same thing as 0.01. And for this type of problem, which is a confidence interval for an unknown population proportion, the margin of error is z critical times the square root of p hat times 1 minus p hat over n. So we got a little bit more work to do here. So the desired margin of error we want is 0.01. The z critical for the 95% confidence interval is 1.96. P hat is 58 over 1020, so what is that? Now guys, I'm going to go out to about 4 places for technical accuracy. So I'm going to go out to 0.0569. Now I need 1 minus that. So 0.9431. Over the n. So how are we going to do this? This is going to take a little bit of work, right? First thing I want to do is I want to divide both sides by 1.96, and then the spirit of the last problem, I want to work all this out so in the end I create a formula that I can use for future problems. So guys, this cancels, as you guys like to say. So on the left hand side I get 0.01 over 1.96. And on the right hand side I just have this stuff. All right, next step you would think would be what? Square both sides? So on the left-hand side, I have 0.01, 1.96 quantity squared, and over here I have 0.0569 times over n. Now, remember that in the previous problem where I told you we could switch things on the diagonal? Well, guys, if I think of all this as just over 1, now, a complex fraction, but if I can think of this as being my numerator over my denominator, that tells me I can just switch all this with n, top to bottom, go vertical. So I can bring the n up here and have n over 1. Now, I'm not going to write the n over 1 because that's redundant. And I can take all of this and put it in the denominator. Now, let's see if we can put that crazy mess into our calculator. And it turns out it's not really that hard to do. So .0569 times, well, I'll tell you what, let's do this. 0.0569 times 0.9431 divided by, now I need all this in the quantity, 0.01 divided by 1.96, but I need that bottom all squared. Parentheses are critical here. Always round up, so my answer would be 2062. So I'm glad it turned out this way. Traditional rounding rules, this would round to 2061. But when you're solving for n, you throw out traditional rounding rules and always round up. So guys, our answer would be 2062. Now, why did I do all this work here? Why didn't I just multiply this stuff out and get my answer little by little? Well, guys, because I wanted to create a formula. So when I run into future problems like this, let's think about the form of this answer. I essentially have something times something, right? Well, in this problem, what role did the .0569 play? That was my p hat. What role did the .9431 have? That was 1 minus p hat. 0.01 was what? My margin of error. And the 1.96 was the z critical. It's 1.96 because it's a 95% confidence interval. But if I wanted a 90% confidence interval, I would put 1.645 there. All right. Now, guys, great time to step back and do a little bit of talking before we go any further. All right. Sneaky quiz coming up, boys and girls. I think this is sneaky quiz number 4. It's not even statistical. Guys, from here on, we're going to get into tougher stuff. And I can tell from some of the emails that I got from some of you, extremely frustrated when you were working the midterm study guide. I have no doubt that you had watched all the videos. But when it came time to put it all together, there were things that you didn't remember. And instead of going back and watching the videos, you thought, well, it's going to be easier just to email Dr. Darbro. Okay, whatever. I'm here to help you. That's fine. But guys, it is going to be critical that you keep a notebook from here on out. Maybe you're already keeping a notebook. And if you are, well, you're going to get an easy sneaky quiz score, okay? If not, you need to start creating a notebook for the second part of this class. Guys, we are going to go over so much stuff. And I'm a nerd. This is what I do. I'll remember that 6 weeks from now, 8 weeks from now. You won't. And instead of going back through the videos and watching multiple videos and trying to find the place where I taught that, if you've got this information in a notebook, it is going to be advantageous and beneficial for you when it comes time at the end of the course to study for your final exam. So I'm not going to officially require a notebook, but I am strongly suggesting, please keep a notebook. Guys, I can't even write this without thinking of the movie A Notebook. I've watched it twice. I've cried like a baby both times. And I consider myself to be kind of a, I don't know, play sports, love to lift weights, scuba diver, kind of a guy's guy. I don't know, whatever. Shoot, that movie does it to me. So far more information than you ever cared to know about your stats professor. Okay, sneaky quiz number 4. Send an email to... I feel like I just lost half of my man card by telling you all about crying at the notebook. Okay, anyway, send a notebook. Shoot, send an email to ddarbro@shawnee.edu. Title it. So the subject line, I want you to write quiz 4 STAT 1800, and in the body, tell me I intend to keep a notebook for the remainder of the semester. This is due, I think your all's assignment is due at 11 p.m. whenever. This is due by 11 p.m. Whenever your assignment that corresponds to this video is due, that will be the last second that you can turn this in. And you know, if you're like me, and well, not like me, I would keep a notebook because I know the importance of it. But if you just don't intend to keep a notebook and you don't want to lie, write this out. I intend to keep a notebook for the remainder of the semester, and come down here, disclaimer, I probably won't, but I want the points for the sneaky quiz. If you do that, it'll make me smile, and you'll get your points. But guys, seriously, you need to keep a notebook. All right, next question. A catalog sales company promises to deliver orders that are placed to the internet within 3 days. Follow-up calls to some randomly selected customers. Shows a 95% confidence interval. That arrival on time is 88%, plus or minus 6%. Now, what's all this tell me? First of all, I know the confidence interval is 88 minus 6 to 88 plus 6. And I know that my sample is smack dab in the middle, so p hat has to be 0.88. Margin of error is big number minus small number. So the margin of error is plus or minus 6%. How many customers were included in this sample? Well, I know that my margin of error is a function of the number of customers. So my margin of error is 6%. Guys, never, ever, ever use the percentage. Use the decimal. 95% confidence intervals. This is 1.96. P hat resides smack dab in the center of the interval, so that's 0.88. 1 minus 0.88 is 0.12 over n. All right, so I'm just going to do that very quickly on the calculator. So I have 0.06 divided by 1.96, square that. And so I have 0.88 times 0.12 divided by the answer. So I get n is equal to 113. How many customers would the company need to sample to reduce the margin of error to 3%? So in other words, cut it down to half. Now, we don't always seek to cut this in half, but in this case, they want to reduce it to 3%. Well, guys, I just showed you that the sample size for these types of problems can easily be found using this formula. So let's use it. P hat, 0.88. 1 minus p hat, 0.12. Margin of error, we need is 3%. Guys, never use 3%, use a decimal. And the z critical is 1.96, and all of that is squared. So I'm going to put that in my calculator, left parentheses, 0.88 times 0.12 divided by 0.03 divided by 1.96, quantity squared. So 451 people would be needed to reduce the margin of error from 6% to 3%. Guys, I think there's another problem. I didn't print it out, but I'm going to open it up here on my other computer. And the other problem talks about, says the environmental, so hopefully you've got this in front of you. So I don't have any way to show this on this screen because it's on my other computer, but the Environmental Protection Agency would like to estimate the nitrogen oxide emissions for all cars. They obtained the following data on N equals 7 vehicles. The population standard deviation is unknown. So construct a 95% confidence interval. So guys, what I'm going to do here is I am going to go to StatCrunch, and in variable, shoot, better get up to number 1. Variable 1, I'm just going to type these numbers in. So the first number is 0.06, 0.11, 0.16, 0.15, 0.14, 0.08, and 0.15. So double check because my grade's at stake. Well, actually, only my reputation's at stake now. So I want to. But when your grade's at stake, it's always good to double check. All right, so this is going to be a little bit different because we've got the data, the raw data. So I'm going to go to tstat. I'm going to go to one sample, but I don't go with summary now. I go to with data because I have the raw data. I want to select variable 1. Again, I want the confidence interval 0.95, and I want to compute. So guys, the confidence interval would be 0.085 to 0.157. So I'm going to write that down over here. So 0.085 to 0.157. All right? Easy stuff, right? All right, gang. Next question is, what's the margin of error? I don't know how many times. I wish I had $1 for every time someone would do this. A student will see an answer like this, and they'll convert that to 8.5% because they always have. Guys, these numbers don't have to be percentages. They're not. This is just a straight T interval that's trying to estimate the mean nitrogen oxide emission for all cars. So the margin of error here is just going to be the big number minus the small number divided by 2. This is not a proportion problem. So, but it looks like 1, doesn't it? But it's not the way it works. Okay, let's move into some questions that you're going to encounter on my math lab. Okay, so first type of question, if you want to be 90% confident of estimating a population mean to within a sampling error of plus or minus 5.8 with a standard deviation of 20, then what sample size is required? Well, what I'm going to do is I'm going to, if I were you, is I'm going to go back into my notes, and I'm going to see that Dr. Darbro gave me a formula for this, and that formula was N equal sigma C star margin of error quantity squared. So I can put the correct values for this problem. A population standard deviation is 20. The Z critical for a 90% confidence interval is 1.645. And my margin of error that I need is 5.8. So I'm going to put that in my calculator. I'm not going to show you, but what I get is I get left parentheses 20 times 1.645 divided by 5.8 quantity squared. Well, I'll show you what I did. All right. And I get 33 as my sample size. All right, second problem. If you want to be 99% confident of estimating a population proportion, to within a sampling error of 0.05, which is plus or minus 5%, then what sample size is needed? Well, I'm going to do the same thing. I'm going to go back into my notes, and I'm going to see that, again, importance of keeping a notebook. Hint, hint. So I'm going to see that N can be found by taking P hat times 1 minus P hat over the margin of error over Z critical, all of this squared. All right, so I need 4 things, right? And I'm going to start in the bottom. So my margin of error desired is 5%. I never, ever, ever use a percent in arithmetic and algebra. Z critical, the Z critical for 99% is 2.576. Again, reason you should keep a notebook. I gave that to you about 2 weeks ago or so. It's hard to remember this stuff. Got to write it down. Now we go P hat is the sample proportion. We go into our problem and we think, oh crap, what's going on here? All the other problems that Dr. Darbo's given me as an example has showed has given has been embedded in some real life problem, but this one doesn't have any additional information about a prior study. So it may seem kind of wacky, but when you get in a situation like this where there's no prior information, you use 0.50 for your P hat. So if P hat is 0.50, then 1 minus P hat also has to be 0.50. So guys, I'm going to have 0.50 times 0.50 divided by 0.05 divided by 2.576 quantity squared. Does it line up with everything we need? Yep. Hit enter. So we need 664 subjects. All right, gang. That's all I got. Don't forget to get me that information. All you got to give me is a statement. If you're really not going to do it, just give me a disclaimer. Hey, I'm just writing this to get my points. It'll make me smile. But I hope you don't do that. Guys, we're going to cover. Seriously, once we get into ANOVA and 2 sample problems and multiple regression and multiple predictors and inference and p-values, guys, you're going to have to write this stuff down. You just are. There's no way around it. So, guys, I'm done. Take care.